Now you're going to see some examples, MCQs in context-free grammar, like Unit 2. So Unit 2 is all about context-free grammar. So here it is going to say about the different types of grammar, what is the context-free grammar, and the normal form. So what is Chomsky normal form, what is Gribach normal form. Okay, so here the first question is, if all the prediction have a single non-terminal in the left side, then the grammar is. So first we should know what is the different types of grammar available, then only we can go for this example. Okay, so first one is like we have unrestricted grammar, 4 types of grammar. Okay, so first one is type 0, and this is unrestricted. So there is no restriction. It is accepted by Turing machine. So you can have any questions in it. Okay, so here we can they can ask a MCQ like what is the automata that accepts an unrestricted grammar. So that is Turing machine. And what is type 0 grammar? That is unrestricted grammar. And type 0 grammar is accepted by Turing machine. So you can have any combination in it. Okay, and here type 0 is accepted by it is unrestricted grammar. So your prediction is of the form alpha tends to beta. There is no restriction. Size of alpha might be anything, size of beta might be anything. Okay, so it is not a matter. And next one is type 1 grammar. Type 1 is context sensitive grammar. It is accepted by linear bound automata. And here the restriction is length of alpha is less than or equal to length of beta. It might be anything, but the length is restricted. Length of alpha should be less than or equal to length of beta. And next one is type 2 grammar, which is context-free grammar. And this is accepted by push-down automata. And here the restriction is length of alpha less than or equal to length of beta. And alpha is a single terminal symbol. Okay, it is a single non-terminal or a single variable. One capital letter is used to represent this alpha. Okay, and it is of the prediction S tends to ABC or something. You can have a prediction of this structure. Okay, so this is your context-free grammar, and the next prediction is next grammar is type 3, which is regular grammar, and this is accepted by any finite automata, NFA or DFA. So here the restrictions are alpha tends to beta, alpha size is less than or equal to beta, and alpha is a single non-terminal. And here one more restriction is size of beta is less than or equal to 2. So this is the restriction for finite automata. Okay, so now the prediction that has a single non-terminal in the left side. So single non-terminal in the left side is applicable for these two categories. For both type 2 and type 3 grammar, you have a single non-terminal in the left side thing. Okay, so we can check with the option. It is whether it is a context sensitive grammar. No, context sensitive grammar, the length of alpha should be less than or equal to length of beta. You can have any number of elements in alpha. So this is not a right an option. Context free grammar, yeah, context free grammar, the alpha is a single non-terminal. So this is correct option. And we have to check out the remaining things too. Unrestricted grammar, no, unrestricted grammar, there is no restriction for alpha or beta. It might be anything and any length. So this also doesn't come. And last one is phase grammar. Actually, phase grammar is nothing but grammatical, normal English grammars. Okay, so this will never comes under our category at all. Okay, so the answer for this question is context-free grammar. And the next one is a word generated by the grammar. So we have to check whether these words are generated by the given grammar or not. So we have 3 variables. Variable is a capital letter which has a prediction for it. Okay, so you have X tends to D, B, and B tends to something, and A tends to something. So we have 3 variables, and there is no specific mention about the starting symbol. When it is not specified, then you have to take it, the starting prediction as this variable, or whatever is the starting one, that will be your start state. Okay, so we are going to draw a pass tree with X as the starting symbol. And for X, you have 2 predictions. One is X tends to D, another one is X tends to BD. Okay, so either X tends to D or X tends to B and D. Okay, so here when you take this prediction, it cannot be expanded further. Okay, since this variable tends to a single terminal symbol, it is stopped but with this. There is no expansion. Okay, so one input that can be generated by this prediction is small d, and that is nowhere over here. All the input starts with B. So we have to take up this prediction. Okay, and the next variable to be expanded is b. So we can draw a pass tree at all like this. This will be easy for you. So now for this b, we have two substitution. Again, this b tends to d or cca. Okay, so when you substitute d, it is a single terminal symbol. When you substitute d, the input that is derived is bd. There is no further expansion, and this bd is none of the option that is given. Okay, so we can say that this substitution cannot be taken. So we have to make a substitution for b as cca. So b can be substituted as cca. So this is the only possibility. So all the option that has BCC has a possibility of getting expanded. So this option cannot be derived, and this option also cannot be derived. Now we have to check whether the option is A or C. So that can be done by expanding A. For A, you have two possible substitution. One is AAB, another one is DDB. So one possible substitution for A is AAB. Then the input actually derived by this is BCCAAB. So it is BCCAAB. You have any option for this? No. We have BCCAA. There is no B with this, so this cannot be generated. So this possible transition is not done for A. So we have to take up the next possible transition for A. So the next possible substitution for A is DDB. So we can make a transition as DDB. So the only left out option that is not cancelled is BCC triple D. So BCC double D is already there. If there is a possibility of deriving this B to D, then sorry, it is D. Then the input, this input is accepted, and you have a prediction as B tends to D. So we can have this possible transition. So this is the correct option for this question. The word generated by this grammar is BCC triple D. Okay, and the last question is pumping lemma for the context-free grammar is used to. We actually know we have a pumping lemma, and it is going to define the rules for, like, you have two different pumping lemmas. One is for regular grammar, another one is context-free grammar. So it is going to prove whether the given grammar or the given language is regular or not. And similarly, when it is for context-free grammar, it is going to see the set of rules to prove that the grammar is coming under a context-free grammar or not. So the option here is the grammar is ambiguous. No, it is not going to verify that. The grammar is regular. No, the grammar is not regular. No. So it is going to prove that the grammar is context-free grammar or not. Okay, so it is going to define some set of rules that is used to prove the given grammar is context-free grammar or not. Okay, thank you.